where we have talked about areas in geotechnical engineering like soil mechanics, foundation engineering, geotechnical earthquake engineering, geology related aspects in geotechnical engineering. And we have also seen rock mechanics and so on. See, generally, whenever we talk about, as of the fundamental courses are concerned, we'll be discussing only about soil mechanics and foundation engineering courses, not the other courses. Like rock mechanics or maybe geotechnical earthquake engineering and so on. Other courses we don't try to talk, or though we try to talk about, they'll be offered in the electives, not as a compulsory courses, because soil as a material is something what we need to understand, because the behavior of the material is very peculiar. So it has very important need for every civil engineer to learn about that. So we have that course as a compulsory course. When it comes to foundation engineering, which is in 3-2. Okay. So we'll focus only on soil mechanics, not on rock mechanics. The reason is behavior of soil is something very peculiar and which changes from place to place, and with time also the behavior of the soil gets changed. But when it comes to the case of rock, because whenever you talk about any structure which is to be constructed on the ground, there are two criteria, as I mentioned in the last class. There are certainly two criteria what we need to be focusing on. One is the bearing capacity of the ground or the subsequent foundation which is to be constructed on the ground. And the second thing is the serviceability. Serviceability relates to that of the settlement of your soil, and bearing capacity relates to that of stability of that particular ground or soil. Okay, so we talk about stability and serviceability. So these two terms are very important in terms of load transfer, what is happening from your superstructure onto the ground. So in order to safely distribute the load coming from the superstructure onto the ground, we need to be subsequently focusing on how the load transfer safely happens from the superstructure onto the ground. So in the process, soil plays a major role, because the soil behavior is changing with loading that is acting on it, with the time, because as the time progresses, due to the load what is getting applied, what is going to happen is the soil layer starts getting compressed. So the behavior and the soil characteristics are changing over time because of the various loads that are acting on that particular soil strata or on that particular ground. So that's the reason we have to be more careful with regard to the soil as a material. But when it comes to rock as it has got what is called as a solid nature, solid particle structural arrangement, which are relatively strongly bonded when compared to that of your soil grain arrangement. So that's the reason why we say whenever you have a rock strata, we consider that rock is relatively a harder material when compared to that of soil, which has got adequate bearing capacity or relatively a higher bearing capacity, and soil which is assumed to be relatively incompressible when compared to soil, rock which is assumed to be relatively incompressible when compared to that of soil. So not much settlements would happen in the case of your rock strata. So that's the reason why not that rock mechanics is something which is to be learned compulsorily as a basic fundamental course. But however, there is an emphasis on knowing about the behavior of the rock also, because you'll have fault, you'll have holes, and you'll have what is called as the cracks in between your solid structure of the rock and so on. Depending on that condition also, obviously the behavior of the rock could be getting affected. And it's also important to know what is the strength of the rock in order to construct a very high-rise buildings over that particular ground, wherever you encounter your rocky strata. So emphasis is more on soil, and when it comes to rock and other subjects like rock mechanics, geotechnical earthquake engineering, you'll have them offered under free elective or open elective courses or domain elective courses, even your ground improvement techniques and so on. So let's start talking what exactly is our soil mechanics course all about, and let's move on with the first unit subsequently, which we are supposed to be getting started in this course. That's the characterization of the ground. So once we say what is characterization of the ground means knowing the characteristics or the properties of that particular soil which you are trying to deal with. Okay, so that is what we are going to be mostly focusing in this particular first unit. Okay, let me get started. What exactly is this soil mechanics all about? As certain statements I have listed here. So which says what exactly is my soil mechanics is all about. So you can go through those particular points which I have mentioned. Soil mechanics is defined as a branch of engineering which enables an engineer to know theoretically or experimentally the behavior of soil under the action. What action you are going to have? We are ultimately learning in the soil. What is that ultimately we are learning from the soil mechanics course means? We are trying to understand the behavior, engineering characteristics of that particular soil, both theoretically as well as experimentally. How do we understand the behavior theoretically means? We have various theories which are developed by different people upon based on their research. Okay, so depending on those theories, we will be able to estimate how much is the bearing capacity of that particular soil, or how much settlement we are going to be having in that particular soil, and so on. And on the basis of that, we'll certainly understand. And depending on the soil samples which are collected from the field and taken to the lab and subsequently carried out the various tests to understand their respective properties. So both based on theoretical knowledge and as well as based on experimental knowledge, we'll try to understand what will be the condition of that soil, and depending on the condition of the soil, you'll try to think of how the structures are to be designed on that particular soil, and so on. Now, under what different actions you need to understand the behavior means, under different loadings, whatever are expected to be coming on the ground, which could be either static in nature or which could be either dynamic in nature, and due to the gravitational forces itself, that means due to the self weight of the soil itself, how does the behavior of the soil exist, and due to the existence of water in the pore spaces, we'll be trying to talk in detail in later stages. What does this pore space mean? What does that pore spaces contain, and how does the water affect the behavior of your soil, and so on. And we'll also see the effect of temperature, because how does the effect of temperature plays a role in the behavior of the soil? All that aspects we'll try to understand in this soil mechanics course. And according to Carl Terzaghi, as I told you in the last class, Terzaghi is said to be the father of soil mechanics. Though being a mechanical engineer, his contributions to soil has been enormous, and subsequently has been named and called as the father of soil mechanics because of the amount of work that he has carried out with regard to this complete geotechnical engineering aspects. So according to Terzaghi, soil mechanics is the application of laws of hydraulics and mechanics to engineering problems dealing with sediments and other unconsolidated accumulations of solid particles produced either by mechanical or chemical disintegration of rocks. So ultimately, how does Terzaghi talks about the soil mechanics means? It is the application of laws of hydraulics. Laws of hydraulics means relates to that of flow through the soil, and mechanism of the forces what are acting on the soil relating to that of the engineering problems that we are going to be dealing with relates with ultimately relates to that of the sediments. Sediments are nothing but your soil solid particles that we will be talking about. So which are generally formed either by physical or chemical weathering process. Okay. So some other statements regarding what does soil mechanics mean again. So soil mechanics is a branch of science that deals with the study of physical properties of soil and behavior of soil masses subjected to various types of forces. So as I told you, it could be external load, it could be your self-weight of the soil itself, or any other external actions. It could be wind effect, it could be your other structural aspects. Whatever it could be, understanding the behavior of that soil, response of that soil under different loading conditions is what we'll try to learn from this course. So why is this soil mechanics course very important for a civil engineer means? It's important for a civil engineer to understand the properties of soil as like the other materials, because when we have talked about other materials, which is cement or steel or concrete, the properties of those materials are more or less constant. They don't change much from company to company which is manufacturing it, or over time also you will not see much variation. Yes, we'll have the effect of creep and other aspects in those materials also, but however the relative changes what we encounter is less when compared to that of the effects that you see in the case of your soil. So civil engineer must study the properties of soil such as its origin. Where does that origination of soil happen? and grain size distribution, what are the different sizes of grains of particles existing in that particular soil, and its capability of draining the water, whether the water will pass through that particular soil or whether the water particles will be accumulated within the void spaces in the soil, and so on. How much compressibility that particular soil has got. Compressibility nature refers to that of compression. How much compression will happen in that particular soil due to the loading that is expected to be coming on that particular soil, and shear strength of the soil, and load bearing capacity of that particular soil. So to know about all these characteristics of that particular soil, it's very important for every civil engineer to know what is this soil mechanics all about. Unfortunately, soils are made by nature and not by man. This statement is very important for everyone to understand, because when it comes to steel or cement or concrete, these are man-made materials. So we have a control on how the behavior of those materials should be. But when it comes to the case of soil, as soil itself, as we mentioned, it's made by nature. It's not the man-made process. So soils are made by nature and not by man, and the product of nature are always complex. So the material which is made by the nature itself, so the behavior of that material is certainly complex, which varies from place to place, and it's not going to be uniform from place to place. And with the time also, the characteristics of that material is getting changed. So that's the reason it's very important for everyone to understand its behavior. So how did the soil originate? From where did that soil origination happen, and over what time or how much time is certainly required for the formation of the soil layer, and so on. Let us just try to have an idea. So soils are slowly renewable resource. We don't call them as fast renewable resources, because in order to have 1 centimeter layer of soil to be formed, it takes some hundreds of years to thousands of years in order to have 1 centimeter deposition of a soil layer on the existing ground. So that's the reason why we say it's a very slow process, but certainly it's going to be a renewable resource. From how can you say, sir, it is a renewable resource? Because you cannot have the material getting decomposed. So the material remains there, but certainly what happens is that the way how that material was earlier would certainly get transformed over time into some other characteristics, but however the material remains there. And it takes hundreds to thousands of years for soils to develop. In order to have a small centimeter layer of soil formation to happen, it takes minimally hundreds to thousands of years for certain formation of the soil layer. But they do grow, change, and develop over time. Now, ultimately, from where this soil formation happens means it's all about understanding from rocks. So the process of this soil formation gets originated from the weathering of rocks, which you have already learned. Okay, so just to have an idea, we'll try to go through those points again. So obviously, you know what does a rock mean? Rock is nothing but it's a solid structure, or a solid particles which are strongly bonded to form a structure, and which we are calling it as a rock. Rock is basically broken down from the parent material into small pieces. And why does that rock particles are getting broken down from the parent material means because of various reasons. It could be either due to some physical action, or maybe be due to some chemical action, or it could be due to some biological action also. So because of all these various reasons, ultimately we see the disintegration of the particles happening from the parent rock material, and that so-called disintegration of particles is what we call it as weathering. Weathering is nothing but it's the process in which we see that your rock particles get disintegrated, or rock gets broken into small particles or small pieces, and gets separated from the parent material and gets deposited nearby the rock itself, or get carried away to some other new place and gets deposited there in order to form what is called as your soil. Rock is basically a solid bed which is a mixture of minerals of different kinds and proportions as well as properties. Okay, so as once you start talking about rocks will have different composition of minerals present. Depending on the minerals present, depending on its chemical composition and so on, you will have different types of rocks getting evolved. And once you say you have different types of rocks, obviously from the weathering process of those respective rocks, the so-called soil formation, what is happening, would also result into different types of soils. Minerals, which are said to be pure inorganic elements, are compounds of a definite chemical composition, usually a crystalline in form. So these minerals certainly they are in literature. If you come across how many minerals are available in our earth crust, if you want to explore, so you will find there are some thousands to lakhs of minerals available in the literature. But however, it's not that all those minerals are going to be predominantly available, but certain minerals in some type of soils are very much predominantly available, whereas certain minerals are very much limited available. And it's not that all minerals are going to be very much problematic in nature when they are present in soil. So all that we'll try to understand, or in rather we'll try to revise everything what you have learned from the previous courses. So even due to the so-called nutrients, which are nothing but the composition of salt material or ions which are present in that particular solutions, will also get dissolved in your soil, and all these are responsible for in defining the characteristics of that particular soil which is getting formed. So ultimately we understood that soil origin happens from disintegration of the rock, that's a parent rock. From the parent rock, when the particles are getting broken down in order to form what is called as a soil. Okay, so just to have a brief idea of what does rock mean, we have understood. And we also know that rocks are broadly categorized into three types, which is nothing but igneous rocks, metamorphic rocks, and your igneous, sedimentary, as well as your metamorphic rocks. So you know what does igneous rock mean, how does the formation of the igneous rock happen, and from the igneous rock, how does the sedimentation happens, that's the so-called separation of your solid grains from your rock. How does it happen? It's obviously happening from what is called as a weathering process, and from the weathering process, your small particles are getting separated from the parent rock, and those small particles we call them as sediments, and those sediments gets carried away to some other place, and they get deposited in order to form what is called as another type of rock, which is sedimentary rock. Each sediments get deposited one layer over some number of years, and next layer over some other number of years, and ultimately results to have a transformation from igneous rock to that of your sedimentary rock. And from the sedimentary rock to that of your metamorphic rock, you have the effect of temperature and pressure, which is resulting in the transformation of your sedimentary rock to that of your metamorphic rock. Sir, is it compulsory that from sedimentary only metamorphic rock should form, or from igneous rock only sedimentary rock should form? No, it is not like that. So it's basically a cyclic process, from igneous to sedimentary, sedimentary to metamorphic, and once again from metamorphism. Due to the process of metamorphism, we'll see the melting of rock happens, which results in what is called as your molten magma, which we call it as your molten magma. And due to the deposition of that molten magma below the ground or above the ground, in the cooling process, we try to have your igneous rock formation. If it is above the rock, if it is above the ground, if the molten magma is getting deposited and cooled down, you get what is called as your extrusive igneous rock. If at all that molten magma is getting deposited below the ground level itself, that so-called rock formation which is happening is what we call it as your intrusive igneous rocks. So obviously I have touched upon what is that igneous rock, sedimentary rock, and metamorphic rock mean. So we'll just try to go through that. Yeah, this what is said, we call it as your rock cycle. How does the rock cycle or rocks, how does they get transformed from one to that of the other is what we say. Okay, generally we don't specifically mention, okay, this rock formation happened at the first and then went on to have another type of rock and so on, because it is a cyclic process, as I told you earlier. So rock formation due to the molten magma, that liquid molten magma material, depending on its deposition and upon cooling of that particular molten magma hot liquid, so you get what is called as your igneous rock. As I told you earlier, from the igneous, it is not compulsory that you should have your sedimentary rock. Okay, you can also have what is called as from the igneous to that of your metamorphism. Due to the process of metamorphism, you can have your metamorphic rock formation, or from your metamorphic rock you can have your particle disintegration happening. It may not be only from your igneous rock that weathering process should happen. Even from your metamorphic rock also weathering process can happen, and which can result into what is called as your sedimentary rock and so on. But in general, we say, okay, from the molten magma we get what is your igneous rock. Due to the weathering process and erosion which is taking place in your igneous rock, you get what is called as your sedimentary rock, and due to the metamorphism process what is happening in the sedimentary rock, you get what is your metamorphic rock. And once again, due to the partial melting of your metamorphic rock, you get what is your molten hot magma liquid, which cools down in order to form your igneous rock. It's a cyclic process, what we say. So coming to what is meant by soil, how do we describe the soil? Okay, soil is basically nothing but it's an unconsolidated agglomerate of minerals. Agglomerate of minerals means it's a composition of different minerals which are present in that mixture, which is certainly forming you what is called as soil, with or without organic matter found at or near the surface of the earth crust, with which or upon which civil engineers will build their structures. So whatever that soil that you are referring to, on which the civil engineers are going to be constructing their structures, so that soil, what does it contains means it contains different mixtural proportions of minerals, which is certainly forming you what is this called as soil. Now when you look at soil as a mixture or soil as a material, now as I told you in the last class, what does that soil material contain? Basically soil material, it is going to contain, as I have already told you in the last class, it is basically called as a three-phase material. Three-phase material means if I am taking some soil sample in my hand and if I just try to examine what does that soil contain, I could see some solid particles which are said to be unconsolidated or uncompressible. You cannot try to compress that solid particle, which is certainly said to be there is no change in the volume of those solid particles, ideally speaking. Okay, so your soil basically contains the solid particles, solid matter which is present in the composition, and in between each of those soil grain arrangement you'll have some void spaces, the openings, whatever we are talking about. In between the interlocking of your particles, there will be some void spaces, and those void spaces can either be said to be filled by water or can be either said to be filled by air. And so ultimately when you look at a soil or soil material, so you are going to have three different phase materials that are existing, three different phases existing in it. That's a solid phase, liquid phase, and the gaseous phase. Solid phase is what we understand as the solid structural nature of the particle, and liquid phase refers to that of the water which is present in the void spaces, because in soil mechanics we talk about the liquid medium which relates to that of water mostly. Okay, and the gaseous phase, it's not that different other gases are not present in the void spaces. Yes, other gases also would be there, but general gaseous medium which we are referring to is air. So when you look at the composition of the complete soil, what does that soil generally contains? It contains the 45% of mineral particles and 25% of air, 25% of water, and the remaining is 5% corresponding to the organic matter. Organic matter also will be available, will also be there in that particular soil. Sir, from where does the organic matter comes from? So it's nothing but it could be because of the buried leaves, buried plants, or it could be because of your solid waste deposits which are being deposited on the ground, which certainly gets dissolved with the soil particles and will get mixed with the soil grains. So these all put together will form you what is called as your soil. Organic matter also we in turn refer it as your solid material. So ultimately, as we have told, how does this soil formation happen basically? So as mentioned earlier, the soil formation happens from the weathering of rocks. Okay. Now, what does this weathering of the rock means? It's the disintegration or breakdown of solid grain particles from your parent material. So those broken down particles are certainly getting deposited in order to form what is called as the soil. So weathering is the process of breaking down rocks by physical and chemical process into smaller particles. It's a process by which you are trying to break down your larger particle into small particles, resulting in the formation of your soil there. Broadly, in general, we say there are two different types of weathering process. One is a physical weathering and the other is the chemical weathering. But apart from this physical weathering, or physical, otherwise also called as your mechanical weathering. So what does this physical or mechanical weathering means? It's all due to the external action. External action, it could be due to what is called as your erosion, or it could be due to your effect of temperature. It could be due to some external loading acting, or whatever could be the reason. So because of which there is a breakdown in your parent rock material into small broken pieces, ultimately resulting in the formation of your soil. And other broad category is your chemical weathering. When it comes to chemical weathering, due to the presence of chemical mixture in the void spaces of your core structure of the rock, or due to the presence of different chemical composition ions, resulting in the breakdown of your rock material, is ultimately causing the formation of your soil. Apart from this physical weathering and chemical weathering process, there could be other process by which also you see the breakdown of your larger particles happen into small particles. So that is what we call it as your biological weathering. Basically, this biological weathering is caused by the activities of living organisms. For example, the growth of roots of the plants or buried material. What happens when these roots are getting percolated to the rock? Let's say I have a rock strata, and through that rock strata, there I have a tree where the roots of that particular tree are getting penetrated through the small tiny void spaces which are present there. And once you find those roots are getting penetrated through that particular rock strata, as the root tries to develop a pressure, because the root has to penetrate when the process when the root is trying to penetrate through that rock strata. So root tries to exert a pressure inside that void space, and due to which the rock, which is relatively large, starts breaking down. That's how you will see the smaller subsequent formation happens. So it's in detail what we have talked about. What could be the various reasons for this so-called physical weathering process? Okay, so it's a fracturing which is happening due to the expansion and contraction whenever there is a variation in temperature. So certainly what we see is when there is an increase in temperature, the material tries to expand. When there is a decrease in temperature, material tries to contract. Due to this repeated action of expansion and contraction, ultimately you are going to see the failure or breaking happening in your soil grains. Or it could be due to your frost action. Frost action means, let's say you have some small cracks already existing or small void spaces existing in the outer surface of your rock strata. So in that small void spaces, let's say water got deposited, and due to that water which got deposited there, if the temperatures are very low, then what would happen is water gets transformed to ice, and due to that presence of ice, what you are going to see is the breakage in the rock structure would take place, and resulting in the formation of your small particles, and which leads to what is called as your formation of the soil. So sometimes it could be because of your erosion or wear and tear effect. Erosion means when let's say for example I have a rainfall. when there is a rainfall, due to the movement of water, water particles, what does they do? They try to exert some force on the surface of the rock body, and due to that force, due to that rubbing action, whatever is getting developed, so we try to see the top surface particles are getting rubbed due to the movement of water, or it could be sometimes due to the wind effect. So you see some particles will start getting separated from the parent material, and they'll be getting deposited. And coming on with what could be the different reasons for your weathering of rock due to the chemical action. So it's all due to the dissolution or the chemical compounds which are present in the water mixture. When the water interacts with different minerals that are present in that particular rock. Let's say, for example, you have some type of rock in which, as I have told you, like there are different types of minerals present in that particular rock. When the water gets interacted with those particular minerals, so due to the chemical reaction process, whatever is happening between the rock mineral as well as with the water, so you are going to see some calcium carbonate material, or maybe silica oxide, or different other ions getting formed, resulting in the formation of breakdown of your particles there. So from this hydrolysis process, that means when water reacts with minerals that are present in the rock, they create new, softer, different compounds, and those compounds would be certainly responsible for the breakdown of your original parent material. As I have already mentioned, like due to the biological process also, we see what is called as the weathering of rock happening whenever you see the plant roots start passing through your structure of the rock, which results in the formation of the breakdown of your rock structure, and which certainly results in what is called as your weathering. What are the various factors affecting your soil formation? Okay, so majorly whenever you talk about the soil formation, or when you talk about what type of soil you are going to have which is getting formed from that so-called weathering process, means it basically totally depends on the amount of time that a parent material is having in a particular specific topography when it is exposed to the effects of climate and vegetation. So when you have some certain type of rock which is being exposed to different climatic conditions, and with respect to time, because within a small period of time means over 5-10 years, maybe larger particle of this size might break down into small sizes of this size, but over further time, this small sizes particles further breaks down into further smaller, and that further smaller particles will further get broken down into further smaller, and ultimately resulting in what is called as different sizes of particle formation in your soil or ground formation. So basically the type of soil which is getting formed depends on what is called as your parent material from which your weathering process is taking place, depending on the climate where this so-called weathering process is taking place, and depending on the life or the time duration what you are referring to, or life in the sense the locality or the kind of natural existence what is available there. Depending on that, we'll try to understand how does that soil formation happen. Sometimes, let's say you have trees and other plants, vegetation available in that location. So when those material gets buried, you have decomposing material available, organic matter present in that particular soil which is getting formed there. And when you have the organic material, whether that organic matter, whatever is present, is highly decomposable or low decomposable, depending on that, your nature of that soil, behavior of the soil is certainly getting affected. Depending on the topography, the location where this so-called formation of soil is happening, or how much time is there for this formation of the soil, depending on all these factors, your type of soil, whatever is getting developed, depends. So from the parent material, as we have told, the disintegration or the separation of your rock is happening, and which is getting broken down into small particles. And if those small particles are getting resided in the nearby parent rock itself. From the parent rock, particles started broken down and they got deposited nearby the parent rock itself. Then upon the formation of all those soil grains, you will have certain type of soils which are getting formed, which we call it as your residual soil. Residual soils are nothing but soils formed in place in the sense wherever you have your parent rock, there itself this particular type of soils are formed. But these residual soils are not very common, they are less common and form slowly from weathering process, because it cannot be formed from a faster weathering process. Because of the faster weathering process, due to that fast action, particles will not be getting settled at that particular location of the parent material itself. Rather, they get transported to some other new place and they get deposited. Small particles will certainly get resided in nearby the parent rock material, resulting in the formation of a residual soil. So self-explanatory, I need not talk about again. Formed by in situ weathering of parent rock to remain at the original place. The top layer of the rock is decomposed into residual soils due to the warm climate and abundant rainfall and so on. In case if that particular weathered material, if it is transported to some new place and if it is getting deposited, because of the mode of transport, so you'll have certainly a different type of soil formations coming into picture. So if those solid particles are transported to some other new place and if they are getting deposited, we call them as what is called as your transported soils. And what are the different types of transported soils that we come across means? So it depends on the medium of transport, whatever is available for carrying the particles from parent material location to that of a new location where the particles are getting deposited. So that medium by which your particles are getting carried away could be because of your river water, it could be because of air, it could be in the way wind, it could be because of your glaciers, because of the ice movement from along your hilly mountain regions. Due to that movement of the ice, which we call it as your glaciers, so due to the movement of that also, particles will get carried away from one place to the other place. And sometimes because of the effect of gravity itself, if you have some soil particles or rock particles getting disintegrated from the parent material, which is on a slope, so due to the effect of gravity itself, those particles will be getting carried away. And even because of what is called as the effect of volcanoes, you'll have the particles getting carried away from one place to that of your other place. So once again, slides is very much self-explanatory. I need not be talking much about it. So depending on the mode of transport, you talk about those soils that are subsequently getting formed to be different by the nature of or the mode of the transport, what is carrying that particular sediments to deposit and give you the formation of the soil. So glacier will have different types of transported soils, which we mostly come across with. One is glacial soil. What does this glacial soil means? The mode of transport in all these type of soils, what I am trying to list out here, glacial soil or alluvial soil or lacustrine soil or a marine soil or aeolian soil or your colluvial soil, whatever the type of soil it is. So how the nature of that soil would be different from one another means it totally depends on the medium which is trying to carry those particles from parent location to that of the new location where they are getting deposited. So glacial soils are formed by the transportation and the deposition due to the effect of glacial movement or ice, which is trying to slide along your hilly regions. Alluvial soils basically transported by the mode of transport here is running water, and these type of soils generally get deposited along your streams. Okay, so such kind of fresh, generally it's a fresh running water. So such kind of soils, whatever are getting formed because of the medium, what is called as running water, which is trying to carry these particles, is what we call it as your alluvial soils. Along the riverbed, whatever the soil that is available, which we call them as your alluvial soils. Lacustrine soil is nothing but when the sediments are carried away and getting deposited in the case of your lakes. So such kind of soil formation, what is happening in that lake region is what we call it as your lacustrine soils. And in the case if those sediments are carried away and getting deposited in the coastal bed, that is in the oceans or seas that you are referring to. So such kind of soils is what is called as your marine soils. And aeolian refers to that of wind. So in case if the mode of transport or the medium of transport is through wind, then we call them as your aeolian soils. And if the mode of transport or the medium of transport of your sediments is by the gravity itself, then we call them as your colluvial soils. So depending on the nature how they are transported, we'll have different types of soil formation happening. And depending on the type of soil, we'll have the properties of the soil getting changed. And even within that particular type of soil also, the properties of the soil will be getting changed from place to place. It's not said to be uniform. It is not said to be homogeneous. It is not said to have what is called as an elastic behavior. It is not said to be having what is called as an isotropic nature. So what in general when we talk about soil means, soil is said to be non-homogeneous, anisotropic, non-linear behavior. So according to that, we need to know how the response of the soil will be getting changed depending on the various factors affecting that particular formation of the soil. So if you just look at this particular image, which says that you have different layers of soil formation happening. Sir, what does this A horizon, B horizon, C horizon means? It's nothing but C horizon refers to that of a soil layer which got deposited some hundreds of years before, and over top of it you are getting another layer getting formed over last 30-40 years. On top of it you have some other layer which got deposited over last 10-15 years. So that's how, depending on the time which it took for the formation, you'll have different types of layers that you try to represent, and that is what we call it as the effect of time, which will be also responsible in the formation of your soil. As I told you earlier, if it is over a very long period of time, earlier 100 years before, I had one layer. But in the last 50 years, due to some sediments getting carried away from nearby area, some another layer of soil got formed. And when it comes to the age factor, what you are going to be talking about, top surface, or when it comes to the place where you are looking at as a ground, the soil deposits or the soil grains that are available at the ground are relatively new by their age when compared to that of the soil layers that are available at the deeper and deeper layers. Okay. So the more deeper you refer, the age of that particular soil could have been relatively very high, which could be in hundreds to thousands of years. Okay. So yeah, I could mention here 0 year when you talk about when soil first exposed to atmosphere. So that means the top surface, whatever you are referring here, is indicating to the early age of that particular soil. Younger soils show few layers in the profile, but whereas the older soils will certainly have a solid nature of profile, and old soils show more layers. Old soils, when what do I mean by old soil means, that particular soil has got long period of history where the particle deposition is happening there. So old soils refer to more number of particles carried away from different places to get deposited there. That is what we call it as old soils. In such case, if you call it as an old soil, you'll have n number of layers of soil, different types of soil layers available there. If it is a new soil, mostly you'll have more or less similar kind of soil properties existing for that particular soil. I'm not talking about soil structure to be same, but I'm talking about soil type of soil grains or formation of soil particles existing there would be more or less similar. So with this, I'll stop the discussion for today. In the next class, we'll start talking about soil, what exactly it's all about. As I told you, it's a three-phase material. So what are the different phases it contains, and depending on those three phases, what are the different nomenclatures, more commonly used nomenclatures in this soil mechanics is what we'll start talking about. And I hope all those nomenclatures, whatever I'm going to be talking about, is not new to you. But however, it's very important for us to understand all those nomenclatures before we get into the exact soil mechanics